You may know I do a lot of repairs on audio and video equipment and other electronics too. And there was a case a few months ago when I was working on a very large and heavy massage chair. And it took some time to identify that there was one tiny little component there, a Zener diode, had gone short circuit, and it was short circuiting the whole power supply. And it took me some time to find that on the board. Even though it was shorting out the entire power rail of the machine, I couldn't easily detect where it was. What would be really cool for this sort of thing is a thermal imaging camera. Then you could see the hot spot. And they're also good for things like especially computers where you get one chip that's very hot possibly, and that can identify where the fault is. It's not like it's a solution for all repairs, it really isn't. But they can, under some circumstances, save an awful lot of time and trouble. And I've been wondering about buying a thermal imaging camera for some time, but they are stubbornly expensive. And some of the ones that you can get around the sort of £300 to £400 area are very low resolution. By the way, even high resolution is quite low resolution in these things. 256 by 192 is high resolution because you can actually see things, but some cheaper ones are only something like 60 by 80 pixels. So it's very hard to actually identify what you're looking at. In this sort of £300 to £400 area, that's what you're looking at. So they're very limited. There's no real chance of ever getting hold of a high resolution. Wonder what's in this then. It's a real thermal imaging camera. Wow. Oh, this is a fantastic piece of kit. Let's see if this can help us with electronic repair. A thermal imaging camera is capable of being used for many things, automotive and commercial and buildings and all sorts, but we're going to concentrate especially electronics today, though we'll look at some of the other things as well. Right, okay, let's unbox it and see what we have. Start with a good carry case. Product certificates. So it's manufactured end of last year. Instructions, not quite as scary as it looks because it's in multiple languages. So as it says, you can apply the camera in home heating, water leak detection, agricultural, it can be used on its own or USB mode to work with a Windows-based computer. That's we'll be connecting it to my workshop computer. What's in the box? Power adapter, user manual we have, the main unit, a USB cable and a carrying bag. Type C port. Oh, I do like Type C. So much better than mucking about with older USB types. USB mains adapter. That looks decent quality. So that's 5 volt 3 amp. So it's quite a high charge capability. The main unit itself. Notice a tripod mount. That's ideal if you need to leave it on a job. SD card to get you going, which is 16 gigabytes. So that's a useful amount to get started with. And USB-C cable. Looking at the specifications, 256 by 192. So in thermal imaging cameras, that's a high resolution. You can actually see what you're looking at rather than just getting blobs. Measurement range in Celsius, -20 to +350 C. That's easily wide enough for any electronic work. And measurement accuracy, ±2 degrees. Battery capacity, 5,000 milliamp hours. So the battery should be able to run for a decent amount of time. Let's have a look at the specifications. I think it actually says 12 hours running time. Okay, we'll get it charged up a bit. Charge it there, and we'll put the supplied card in. See the space there for a card reader, an adapter if you want one. Okay, we'll insert it that way round so the pin's towards you. The product overview part of the manual just tells you how to get going if you want to use it standalone. So we have, obviously enough, the power button, return on the menus. There's an albums, so you can store different sections in different places. Flashlight or torch in English. So those two LEDs are a torch, that's that button. Navigation and OK in the middle. Let's take our protective film off. Though it looks clear enough, you could probably leave it in place actually. Right, whilst that's charging a little bit, I want to show you what I've set up. You'll remember, if you've been watching my channel, that I had that very large, I call it a rumble chair, but it's a massage chair, and I picked it up with a fault. It was dead, and after some investigation it became apparent that the power supply was working fine. It was providing 5 volts to a main board, but there was something short circuit on that board, and it was dragging the power supply down to a fraction of a volt. So I had to bring the board up into the workshop and go probing around looking for minimum resistances to try to find which component was shorting out the 5 volt rail. This is an alarm control panel, and when it works that LED will flash. But I have soldered that very same defective short circuit Zener diode across the 5 volt rail somewhere on this board. So how are we going to find, using a thermal imaging camera, where that component is? And what I propose we do is we power up the board, leave it for a little while so that the defective component will heat up, and we should be able to see it on the thermal imaging camera rather than having to go through all the pain of trying to find the lowest resistance point. Now in the case of the massage chair, that could have saved a huge amount of time, because I could have left that main panel in the machine. The power supply was working, the current was being dumped into the defective Zener diode, and we could have used the thermal imaging camera to see the hotspot on the board. For a moment I'm going to run this in a standalone mode. There are 3 sort of ways of using this. One is stills in standalone mode, so you can press the trigger and it'll take a photo, but it does more than that. It doesn't just take a JPEG image of what's on the screen, it actually records all the data of the temperatures, and it records that as a separate file. Both of those files can be downloaded to the computer on the USB cable, and the software that comes with it can then analyze the image. You can click on the image and you can see the temperatures all over it, which is very useful indeed. So you can analyze the information offline. A second way of operating it is with a movie, so you can just press and hold the trigger and you can take a movie which is purely video information, so you can't analyze that later. And the third way of operating it, you go through a menu and you change your setting in the menu, you then plug into the USB port and you can analyze in real time on the PC. For the first instance, we're just going to do the simple standalone mode, so it's running on its internal battery. Here is our sample board. So this is the board which I have modified with the very same faulty Zener diode that came out of the massage chair. So that diode was across a 5 volt rail and shorted the rail out. I've replicated that here. We have a power supply going into this scrap circuit board, is actually part of our alarm control panel, and very briefly it's got a bridge rectifier smoother, 9 volt regulator followed by a 5 volt regulator here, and that 5 volt line we have shorted out somewhere with my defective Zener diode. Now in the massage chair it will have been taking the full 1 amp or so that the 7805 regulator was supplying in its short circuit mode. Here I've connected it to a power supply. I'm going to current limit this to a little under an amp, partly because that 7805 doesn't have a heatsink, also because of 1 amp fuse. So we'll take 600-700 milliamps, should still generate plenty enough heat for us to be able to see the defective diode. But we'll also see heat in the regulators and other components in the power supply here. So you have to look at it with a certain amount of intelligence to see where the cause and effect is, to see which is the defective component and which components here are just getting hot because they're working hard. Immediately we are working, and it's got a good update speed. It can refresh at about 20 frames per second, whereas some of the low resolution ones are sort of about 9 frames per second. So we'll put that on. Right, this is now in its faulty condition. We have 700 milliamps or so flowing into our defective diode. How can we find it with this? I'll do this actually as a movie so you can see it. So we press and hold the trigger and it starts counting in red on the display there, and I can scan across the board. You can see the hot components here from the regulator, and in fact even the diodes seem to be getting quite hot, the rectifier diodes. And we go across the board and very quickly we see a component that's glowing, which is clearly where our short circuit is. I'll end the movie and we can save it, and now we'll take a closer shot of which is our suspect component and save that, and we can analyze the temperature data later. And quite clearly you can see there's a lot of heat down here, and it takes you straight to I'll switch this off before something bad happens. That takes us straight to our defector Zener diode right there, which I've soldered in the circuit board, and that would have saved me heaps of time when I was working on that circuit board on the massage chair, because it just sits there glowing with the full current of the power supply going into it. Right, let's analyze some of that with the software. When I first started this TDView software, it started up in Chinese. Easy enough to fix. 3 dots up there on the top right. Then the second to bottom item is language. Looking now at the photo we've just taken, we can do more than just look at it as a picture. We can look at different temperatures. And you can do various different functions, such as look at temperatures in a certain range or in certain points. So there's a lot of analysis you can do here. You can even do a sort of 3D plot, and we can remove all those regions. So that's a nice way of being able to analyze a picture that may have happened momentarily. You can grab it and work on it later. But how about we also look at the images on screen at the same time as it's being captured? So for that we'd click on the online analysis, but nothing seems to happen, and the reason is we need to change the mode this is in. Go into the settings, system settings, using mode. So setting, USB mode, and we're going to go, instead of it being just a USB disk, it's now going to be USB camera. It will take effect after restart. And now we can reflect this straight up onto the screen in real time. I'll switch my circuit board off, I'll power it up again, and it will all start getting very hot very quick. And there again we can see our defective diode. So now we can see it heating up quite rapidly in real time, and we can analyze it in real time on the PC. And you can see what they mean about this high resolution. You know, it's not high resolution by camera standards, but we can definitely see what we're looking at here. We can see the circuit board clearly. We can even see the background items that I have on my workbench. And we can see our defective diode getting hotter and hotter there. And again, we can look at individual points on there using the same software. I move across to my regulators, I can look at how hot they are. So we have a wealth of information available to us, possibly more than we'd need to for electronics repair, but it's absolutely brilliant how much it can do. Now, I would say if, like me, you're using a desktop computer, this USB cable is likely to be on the short side, so you might want to get a longer, high-quality USB-C cable. It can charge at 3 amps, so you're really looking for a decent cable there. So, of course, you don't want to think that this is a cure-all for every kind of fault, because you need to view it with a certain amount of engineering knowledge. You know, you wouldn't immediately assume that just because a regulator is warmer than everything else on the board that there's any kind of fault there. You need to apply some knowledge. You can see other components here that are warm, but it's completely normal operation. There's a diode there, which is getting a little warm. Perhaps surprisingly, the main processor here is stone cold. We have a resistor, I think, over here that's getting a little bit warm. So that's all quite normal. But it was that bright light coming off the defective diode that really gave the game away on a board that was otherwise dead. So you have to apply a certain amount of engineering knowledge, and don't believe that being able to see the hotspots is everything you need to know about finding a fault on a board. So Scott, you've been playing with this, haven't you? Let's switch it on. It's a little bit slow, isn't it? You press and hold the power button, and then we get this startup screen, and we do hear a clicking noise. You've noticed that a few times, haven't you?
Yeah, it does that a lot.
Presumably that's normal operation. There we go. So you found something about the sensitivity of it, didn't you? Let's have a little demonstration of that. So we're looking at a plain wall there, Scott. What was the little thing that you found out?
Well, the wall here shows up as like kind of purple, but then if you put your hand on it and then leave it for a second, you can see the handprint.
And that remains?
Yeah, because it leaves the heat there.
Should you have a new handprint? So I'll put my handprint there, save it. We've just pulled up that photo, and you can see remarkable detail, that image remaining on the wall for quite some seconds, isn't it?
Yeah, it takes like a couple minutes for it to fade. Like
Yeah,
properly
look,
fade. It's still
we
there.
can still see it, yeah. We get this occasional stalling, aren't we? It seems to be that once you've switched it on, it takes a few seconds to fully get up to speed. So maybe the processor is
another thing that we can demonstrate here is how you can see that the wall is like partly orange and also a shade of purple. However, if I put my hand in front, then it goes like deep purple around it.
Right.
So you can see the colour ranging there.
Yeah, so it's got a kind of an auto ranging. So this is the highest temperature and the lowest temperature in the room or in its scene. And it's continuously auto ranging. So if you get something that's, what I think we're trying to say is, the colour that something is changes depending on not just its temperature, but the surroundings. So if we now give it something of a wildly different temperature, then that wall has gone from being sort of pink to purple because it's much colder compared to the brightest, hottest thing in the image. So it almost feels, doesn't it, is that it'd be nice if you could halt that auto ranging, if you could say, I'm happy for the hottest thing to be this and the coldest thing to be that, and to hold that set of range, because you could be slightly misled in thinking that something's really hot or really cold in a scene, when in actual fact it's just compared to the other things.
And also, if you're trying to analyse something more than a scene, say an entire room, and you want to compare everything to each other, having that makes it much harder to visualise because it's relative to the scene.
But do remember that you can take the photos and store them on the computer, and the computer will give you the actual temperatures. You can go around and look at them all.
Yeah.
But you also found, because you've been through the menus, haven't you?
Yeah.
They're not listed in the instructions, and perhaps we'll do if you fancy helping me later, we'll create a directory tree of the menus, because it's not in the instruction book. But you found we could do an alarm, didn't you?
Yes, I will show you how we do that now. So if we go to the menu...
Let's get it into shot slightly.
Go in shot. It's a bit hard to see. If you put it into the settings, you go to the HI and LO, then it comes up with different, so you can set the temperature for high and low, turn it on and off, and then put if there's an LED alert. So basically if it goes below this temperature or above this temperature, then the LED will go off. However, it would be really useful if there was some sort of an alarm that you could hear.
A sound or some other kind of way.
Or at least a way of being, or an easy way of making it so you can connect it up to something to do that.
Yeah. So can you set the low temperature to what we're going to set? A low temperature alarm?
So we could set that to say 0. I've already got it at 0.
Okay.
So if I turn it on and then put LED alert on.
Right. And we'll swing around to
And then
the
I'll
freezer.
close that. And it comes up with this, the light starts flashing at the front and it's got this triangle that appears on the screen as well. However, it'd be better if you could kind of hear that, because if you're doing something from another room, a light's not going to help.
No, that's right. That's right.
Another thing I found in the menus was Emissivity, which is here. If you can see that.
And it's set to a sort of default, isn't it?
You can't really see that, but yeah. So it's set to 0.95, which is the emissivity of, like, around the range of most objects you encounter. Like, it's the same as, like, water and around the same as just other items that you're...
Not polished, I think.
Like, non-polished items, generally.
It's how much something will emit. You've got to be a bit careful because you can get something that's hot and highly polished and it'll look quite cool. But yes, that for most things, 0.95 covers it. Yeah. Scott, I think when you were rummaging through the menus, you found a few mistakes as well, didn't you?
Yeah, so when it's talking about the capacity, it says M, but it's not specifying what M is. Presumably M means MB for megabytes, but if you weren't aware of, like, if you weren't able to assume that, then you wouldn't know that that's what M meant.
It's talking about, yeah.
It says, when you go to the power menu, it says...
For the shutdown?
Yeah, for shutdown, it says shutter down. And if you go to the palette, where you can choose different colours...
You can change your palettes, which are quite nice, aren't they? You can...
Yes. However, it says rainbow with a capital R and a capital B rather than just capital R lowercase.
Yeah. So it's just typos and things.
It's
so
just
what
a couple of typos.
We'll provide that information to TopDon and they can update their firmware.
So if you look at it, it also has the center spot, which shows what temperature is where you're looking, which is in this top left bit. If you look under it, it says maximum, which is where this red marker is. And then you've also got the minimum, which is where this green marker is. And it's really useful if you're trying to find out what you're looking at, what the coldest bit is, what the hottest bit is. It can be quite useful for that.
So what else have we found when we were looking at the software in particular on the PC?
So the first thing is that when you open up the software, it immediately defaults to Chinese.
Yeah, which I've already shown how to solve
Which we've already shown, but that's still an issue. And then also, at least the first time Dad opened it up...
On one of the PCs.
On one of the PCs, not on both of them, but on one of them, it blue screened the entire PC.
Which was a bit annoying.
You know, could be a bit annoying if you had unsaved files on there.
Yeah.
The software is only accessible on Windows, not on Mac.
Not a great Mac fan anyway, personally, but obviously under some circumstances that could be a nuisance.
So if we go to one of the settings, we can see the temperature scale. I'll show it to the camera here. So you can either choose -20 to 150 Celsius or 100 to 350 Celsius. However, it appears that there isn't really an in-between, that you can't have all of them at once. You can't have the whole range. You can't have -20 to 350. You have to have either. However,
but that said,
it appears that if you do 100 to 350, it doesn't seem to have much of a difference.
It doesn't completely stop it.
It doesn't completely stop it. I think we could demonstrate that if you want.
Okay.
Let's demonstrate that.
It'd be better if you get on screen, huh?
Yeah. It is loading. It does take a second to load.
Right. So you're now changing it to the higher temperature.
I'm now changing it from -20 to 150 to 100 to 350. So now it should have done that. So if we go back, it doesn't... Oh, why is that? What's got the alert? And it says it's negative...
Did you leave the alert on?
I have left the alert on, but the interesting thing is that it's saying negative It's saying like 5 degrees Celsius.
Yeah. So it's...
I'll turn the alert off.
Yeah, it's slightly messed up.
Slightly, I mean, that's our fault probably.
Well, we did it wrong, but the alert came up incorrectly then. Can you get it back on?
Well, it's not just the alert, it's the fact that it's interpreting, it's saying that wall is 8 degrees Celsius.
Right, so this is what happens. If you take it put it into the wrong range,
then it will interpret everything wrong.
the temperatures, it will report incorrect temperatures.
Which makes sense, to be fair. Like, we're not using this for its intended purpose. You're supposed to be using it for 100 degrees Celsius to 350.
So I think if you're in the 100 to 350 area and you see values lower than 100, they're not valid.
Yeah.
That's fair enough.
So I'll just change that back now.
Yeah.
So that's under the temperature scale. And we can just change that
I think
back.
that's going to be what we'd use mostly. Certainly for any electronic work, if you've got anything that's over 150 Celsius, it's probably well fried.
Yeah. But it might be that you're using it for something like a soldering iron though.
Okay, no, that's true. And actually, I have one of my soldering iron temperature set to well over 350 Celsius. So exactly. I guess it'll just report about 350. We're going to have to try that, aren't we?
I mean, we should try that,
We're going to try that.
However, I would recommend also trying to do it lower if you can, lower than 350 to show that it does come up. But
yeah, okay. Well, we'll do that in a minute. We're going to look at some soldering irons. We've got two here. I've got the one which, this is a little one, which runs a bit hot. There is a way of adjusting the temperature on it. Big Clive has done a video on how you can configure it, but I've got it in the default setting, so it runs a little bit hotter than a normal soldering iron should. I find that handy anyway, because I use this one, I tend to use it like outdoors, where it can be a bit windier, so the extra temperature is appreciated. This is my normal soldering iron. It's a Antex from RS Components, and I've set it to 340 Celsius. So can you try and get the hottest point of that, which should be the tip, more or less the tip. And what temperature are we reading on that?
So it says there's a maximum 310 at the moment, but it's going up.
Yeah, I'd only switched on a few minutes ago.
But I need to read the maximum, basically.
Right, the red dot there.
The red dot where you can see what that's following. Top left, we can see where it says maximum. We can see that number going up slowly.
Right.
It's now at around 320.
Okay, so a 340 set point, it's definitely in the order of things. That's doing quite well, actually, isn't it?
Yes.
Right, so what are we reading on this one?
360.
Really? 360?
390. Okay, yeah, and now above 380. Heading to 390.
Wow, that is really hot then. So Big Clive is absolutely right. It's way too hot. And what's the maximum rated temperature of this unit?
Oh right, yeah. So it goes up to 350. So I'm not sure why it's displaying.
And it's reading way higher than that. Yeah. So it might be we're beyond its range. It could be slightly wrong.
Yeah, it might not be perfect here.
So that's a useful bit of information, that if you go beyond 350, it'll have a shot at it anyway.
Well, I believe it's maximum. It will go up to probably 400, because I haven't seen a number above 400 once here. It's gone up to like 397, but not 400.
You know what it doesn't do? It doesn't anywhere hold a minimum and maximum. It'd be handy, wouldn't it, if you could get it to display the highest or lowest temperatures that is read in an X amount of time.
Yeah.
So yeah, it doesn't do that.
There might be a way of doing that, but
I don't think so.
It's not obvious.
No. But what's the highest you've seen?
The highest I saw earlier was like 397. At the moment, it's resting around the 390 range.
Crikey. Yeah, so that is one very hot soldering iron. Perhaps I should look at Big Clive's video again and drop the temperature down a tiny bit. After years of being totally unaffordable, now high-resolution thermal imaging cameras such as this have become available. You know, that's £300 to £400. It's in the sort of price that someone like myself could consider it. Now, this compared to other products of the similar price, there's no comparison. High resolution, high update speed, wide temperature range. You could do online and offline analysis, temperature alerts. The sort of functions you get on this compared to something else of a similar price is magnificent. Now, one of the reasons this one was developed, one of the markets it's approaching, is to be a more cost-effective and user-friendly alternative to something like the FLIR TG165. If you look at the specifications for that one at a similar price, there's just no comparison. It doesn't perform anything like this. So it's useful for repairs like I do, also for things like interior decoration, automotive technicians. There's no end of uses for this sort of product. Now, I think that FLIR have got to watch their backs. They probably had the market for a little bit too long to themselves, and now they've got some incredibly strong competition. I think this model, the TC004, is going to completely shake up the market for thermal imaging cameras, just in my humble opinion. Now, I did ask TopDon, why is it they've been so expensive for so long? And they've told me that there's several sort of factors. One is that the thermal imaging technology has been monopolized for a long time. Well, yeah, I'd agree with that. There's only a few companies that have mastered the core technology, and though the market demand is large, it's not really, the potential's there. It's not really being developed much. These things are not sold in vast numbers yet, so the production costs are still relatively high due to fairly small numbers of production. There's high R&D and manufacturing cost. Most of the thermal imaging lenses are made of germanium glass, which is got a high refractive index, but is transparent to infrared light. The extraction of high quality, high concentration germanium is difficult, resulting in higher costs compared to normal cameras. But germanium, of course, has been around for a long time. Do anybody remember these? OC70 and AC128. But I'm sure that the purity of the germanium in these old things is nothing like what's required for these lenses. So also the production of the thermal imaging detectors requires a lot of auxiliary equipment, black body calibration furnaces, constant temperature and humidity chambers, targets, and also it's necessary to continuously invest quite a lot in scientific research and AI imaging and production processes. So costs are still high, but obviously seriously coming down. Now, this TC004, something you might say it lacks is, if you've looked at some of the more expensive thermal imaging cameras, they can overlay, actually some of the cheaper ones too, they can overlay an image, like an optical image, on top of the infrared image. Now, that might have been necessary for some of the cheap ones before because they had extremely low resolution, like 60 by 80 or even lower, and without an optical image, you just can't see what you're looking at. This higher resolution, you could argue it's not needed so much. But if, for example, you're using this at a distance, say 5 meters, and you're looking at a larger scene, you might still need to have a photograph overlaid of the image, the optical image, on top of the thermal image. There may be some cases where that's important. This doesn't do it, but coming along soon, in a few weeks' time, TopDon will have the TC005 model, so that's a little bit more expensive, but not massively so, and that will include an optical image overlay. Also, it'll go to a higher temperature than this one does, although we saw this one seem to work up to higher than its actual rated temperature, but the TC005, 550 Celsius, whereas this one's rated at 350. So if your budget allows you to go to the TC005, perhaps consider that model when it comes out in a few weeks. We've mentioned there are some menus on this, and I think it might be useful if those menus were available somewhere. The original user book is a little bit small for them to sort of print the whole menu tree out there. So I've worked it out myself, and I will include that in the notes in the video below. Hope you've enjoyed learning something about the TC004 from TopDon. I think it's really impressive. I'll do plenty more content on audio and video technology in the near future. Bye.
Bye.